Hello everyone, welcome to Hydropower. Today we will solve a numerical problem related to hydropower. This numerical was already asked in IOE 2067 Monksir. The question given here is long-term average monthly flow of a large trial river is given below. Here in the table the 12 months and the respective discharge of individual month is presented in the table, and a hydropower plant is proposed on the river to meet the peak demand of 18 megawatt in the month of May of an isolated town where average annual load is 7 megawatt. Topographically permits a natural net height 28 meter and plant efficiency 0.78. If installed capacity is to be fixed to meet the peak demand, determine the percentage utilization of runoff. In second, if peak load increases to 37 megawatt and average load to 23 megawatt in the month of May, the installed capacity is increased accordingly and the power plant is to be operated for only 5 days. Calculate the Pondage requirement to regulate the flow over the period. Here in first case we have to find out the percentage of utilization, and on the second question the pondage requirement of the reservoir. So now we start the question with solution. Here the given data are discharge on the month of day. Discharge of May is equals to 84 meter cube per second. Net head equals 28 meter, and the power efficiency equals 0.78. Now we have to calculate the power. Power is equal to efficiency GHQ equals, efficiency is given as 0.78. G, acceleration due to gravity, is considered to 9.81. Head is given 28 and Q equals 84. On calculating this, 17997.03 kilowatt. Converting this into 7997.03 megawatt equals 18 megawatt. Now solving the first question, that is given by question I. The installed capacity is equals to 18 megawatt and average annual load is equals 7 megawatt. Now for the average P average, now average annual discharge requirement equals rho GHQ, or Q equals P is divided by G, as placing the value of P is 7 megawatt into converting it into kilowatt is divided by efficiency 0.78. G means 9.81, H 28. On solving this, 7000 is divided by 7.81 into 28, 32.672 meter cube per second. Now the average annual discharge is, now For average annual discharge, we have to take the mean of 12 months. That is the data discharge given in the question is 220, 280 plus 250 plus 210 plus 84 plus 84 plus 210 plus 86868 plus 164 plus 0 plus 2492 plus 2156 plus 659 is divided by 12 months, because we are taking the mean of the above. On solving this, we get the value 894.75 meter cube per second. Now the percentage of utilization. Utilization is equal to calculated Q is divided by average annual Q equals 32.672 is divided by 894.75 into 100%, as the question says percentage, equals, solving this, 32.672 is divided by 894.75 into 100%, 3.651%. Now solving for question number 2, where given is peak load equals 37 megawatt. We know P equals Q, where Q is equal to P, efficiency is G, as P means 37 megawatt is converted into kilowatt is divided, efficiency is 78, G equals 9.85 and H equals 28, that is Q is divided by 172.695 meter cube per second. In this question we have to calculate the Pondage requirement. Now Pondage requirement equals 172.695 minus 84 is the discharge in the month of May, as the question says for the 5 days already in question, 5 days already in given in question. 5 days is 24 into converting all those into seconds is equals 172.695 minus 84 into 5 into 24 into 3831,624 meter cube. Pondage means the volume of the reservoir. So the unit is in meter cube. So hence the total volume Pondage is 3831,6240 meter cube. This can also be written as 38 into 10 power 6 meter cube. So today we will end up the class for this month. We'll come again with one new video. Till then, keep on watching our videos and don't forget to subscribe our channel. Thank you.